Hi class, this is a review of the mock test which I gave you yesterday. In the first question I asked you to round numbers down to 4 significant figures and then rewrite them in scientific notation. So we started off with 102.5307. The decimal place is at right after the 2 and 102. But as you recall, in scientific notation, there should only be one number before the decimal, so we had to shift it over twice, and it becomes 1.025. Because we moved the decimal over 2 times, the exponent becomes 10 to the power of 2. And also we had to round off, we had to cut it off at the 5, so we round down, because the next number is 3. In B, the number is 656,980. Which means we cut it off between the 9 and the 8. We're going to round up, but because we round up, this turns into 0 and this turns into 7. So the final answer is 6.570 times 10 to the power of 5, because the decimal had to be moved to between the 6 and the 5 from the position right after the 0. So that's 5 jumps over and the exponent goes up. Recall that the exponent law says that when you move the decimal to the left, the exponent goes up. When you move the decimal to the right, the exponent goes down. It's a good way to remember it. And C, we have 0.0085432110. We're going to cut it off at 5 sig figs. Remember, you don't count zeros when you count the sig figs, so you're going to count from here. 1, 2, 3, 4, 5. We're going to cut it off at, sorry, it was 4 sig figs, sorry. 1, 2, 3, 4. Cut it off between the 3 and the 2. That's where we're going to cut it off, so it rounds down. So it remains at 3. And because we move the decimal to between the 8 and the 5, we get 3 jumps, and so it's to the power of minus 3. 8.543 times 10 to the negative 3. In this one, we're going to move the decimal to between where the 2 and the 5 is, and we're going to cut it off at the 4th significant figure, so that's going to round to a 9. Because it's a 7, we round up, so that turns into a 9. So 2.579 times 10 to the power of negative 4. The last one is going to be pushing the decimal from here to between the 3 and the 5, and we're going to cut it off here. So we're going to get 3.572 times 10 to the negative 2. Don't forget to put your minus sign. In the second exercise, we're going to be adding and subtracting or multiplying and dividing. The rules of significant figures say that when you have numbers multiplied, the biggest number you can have in your answer is equal to the least number of digits in the numbers that were used. If you're adding and subtracting, it's determined by the number that has the least decimal places. You see here we're adding, so you can't have more than 2 decimal places in your final answer. So I did the final answer, I did the answer, and then I reduced it to 2 decimal places. That's why we got 21.11 there. Same thing over here, except now there's only 1 decimal place, so it had to be reduced down to 1 from the original answer you get in your calculator. And in C, I multiplied these 2 numbers. The least number of significant figures was 3, so my final answer could only have 3 significant figures. Here we have a division where there's only 3 significant figures in the denominator, so our answer can't have more than 3 numbers in it. Although you get this in your calculator readout, this is what you would report on the paper to do it perfectly well. 45. 45A, we're converting 0.076 liters into milliliters. You have to know the conversion factor, which is here. There's 1,000 milliliters per liter. You can ask Siri for conversion factors, and he or she will inform you for those simple kinds of conversion factors. So you can get accustomed to that, or just looking it up on Google. Either way, you'll find the answer. But when you're going to be in a test, you'll be given the conversion factors on the board. You just have a list of them on the side of the board to be able to solve the problems. So because you're not allowed to use your phones during a test, otherwise you can look up the answers. All right, so you're 0.076 times 1,000 milliliters per liter. The liters cancel. You get 76. I just want you to realize here, to avoid the use of a calculator, you can look at this as a 10 to the power of 3. 10 to the power of 3, if you multiply by this number, you would get this, 0.076 times 10 to the power of positive 3. But if you move this decimal over twice, you get 7.6, And because you moved it over twice to the right, you can say 10 to the power of 1. You drop that power by 2. And that's how you get the 76, because 7.6 times 10 gives you 76. So you can do it in your head too, if you're familiar with how to use exponents. And 5.0 times 10 to the minus 8. Oh my gosh, I forgot to. It's better to put it here. Gives the best angle. In part B, we have 5.0 times 10 to the negative 8, and we want to convert from meters to nanometers. So the conversion factor is 10 to the 9 nanometers per 1 meter. We can create a conversion factor where meters is in the denominator, so we can cancel out meters. We multiply by 10 to the power positive 9, and when you multiply 10 to the negative 8 by 10 to the positive 9, you get 10 to the positive 1. And 10 to the positive 1 is equal to 10. So you can say 5.0 times 10 is going to give you the 50. 50 nanometers is your final answer. And you're only allowed 2 sig figs because you had 2 in the original. Part C, 6.88 times 10 to the 5 nanoseconds. There's 10 to the 9 nanoseconds in 1 second. So we put nanoseconds on the denominator, then which allows us to cancel nanoseconds. You're trying to turn it into seconds. Then I rewrote the answer, bringing the 10 to the positive 9, which is in the denominator. I put it in the numerator, so it becomes 10 to the negative 9. When you multiply negative 9 and 10 to the positive 5, you get 10 to the negative 4. And then you can put your unit. 6.88 times 10 to the negative 4 is your final answer. No calculator was necessary. D. There's 2 ways of solving D. One is if you know the conversion factor from kilograms to pounds, or if you know the conversion factor from pounds to grams. Either way, you'll get the answer. There's a slight discrepancy in my answer because I didn't use the exact number. There's several decimal places beyond that. I just sort of rounded it. But in the end, it didn't make a difference because I still, when I went to 2 sig figs, which is all you're allowed by this, it's limited by that number of significant figures, you still get the same answer, 2.3 times 10 to the power of 2, or 230 grams. It was actually still the same up to the first decimal place, 226.7 and 226.7. So within reason, you can make little estimates. You don't have to always use the exact decimal numbers, because most of the time it's not going to be a big deal, unless you're selling gold or something. E, it's 1.55 kilograms per meter cubed, and you want to convert it to grams per liter. So there's 2 conversion factors involved. There's kilograms to grams, and there's meters cubed to liters. I'm going to explore this a little bit more because I know some of you are weak in this understanding of the how do you get 1,000 from, but I'll show you that you can figure it out just by playing with the numbers in your head and understanding how the units go. I'll draw you a picture. Anyway, the first one is 1.55 kilograms per meters cubed times 1,000 grams per kilogram. So that allows me to cancel kilograms. Then I want to tackle meters cubed, so I say 1 meter cubed per 1,000 liters, and that allows me to cancel meters cubed. In the end, I also cancel the thousands because there's one in the numerator and one in the denominator, and all that you're left with is grams and liters. So that's the unit that we were looking for anyway, and the number stays the same. The 1.55 doesn't change because you have to multiply by 1,000, divide by this 1,000, gives you the same result. The one thing I wanted to show you with regards to the meter cubed, just going to erase this. If you draw a large cube, you can break it down into all the unit conversions and understand just how it all works in volume conversions. Meter cubed means a cube that's a meter tall, meter long, meter wide. So it's 1 by 1 by 1. So it's 1 meter all cubed, and that gives you still one, because if you distribute the power of 3 onto 1, you still get 1, and then the unit becomes cubed. If you were to describe it in decimeters, given that this is 1 meter high, it's 10 decimeters, right? And so is this, 10 decimeters. And this is 10 decimeters. So if you were to give this volume in terms of decimeters cubed, you'd have to say 10 decimeters all cubed. Well, when you cube 10, you get 1,000. And when you cube decimeters, you get decimeters cubed. But you should also realize that 1 liter is equivalent to a decimeter cubed. So that's how I got that 1 meter cubed equals 1,000 liters. And if you wanted to go with centimeters, what's this height in centimeters? Centi. Guys, help me out here. What's this height in centimeters? I can't hear you. Could it be 100? It's 100. So is this 100, right? And this is 100. So if I want to express this volume in centimeters cubed, I could say 100 centimeters, all cubed. 10 to the power of 2 is another way of saying 100. So 10 to the power of 2 to the power of 3 gives you 10 to the power of 6 centimeters cubed. Or you could say 1,000,000 centimeters cubed. And by the way, 1 centimeter cubed also equals 1 milliliter. So this meter cubed is also 1,000,000 milliliters. How many chocolate milks? If you had a cubic meter of chocolate milks, how many chocolate milks would you have? Yeah, go ahead. If a chocolate milk is half a liter, and you had a cubic meter of milk, of chocolate milk, how many chocolate milks could you make with it? If they sold chocolate milks at Max, you can buy a whole liter of chocolate milk, right? How many of those would you be able to fit in a cubic meter? You have 1,000 liters in a cubic meter. 1,000 chocolate milks. But if the large chocolate milks is half a liter, you get twice as many. So you'd be able to make 2,000 chocolate milks from a cubic meter of milk. Okay, I think I'll stop it there. That's enough for the homework.